make a recording. Okay, the recording is in progress. So let me share with you the presentation and we're gonna start. Okay. So, welcome to the final presentation of the local chapter GIBDET Colombia from Andena. Our project is called Mapping of Agroforestry Systems using Artificial Intelligence. So it's a pleasure to me to make this presentation, and it's a pleasure to stay here with all of you. Okay, so let's get started to explain the problem. Okay, so agroforestry systems are widely known for their contribution to the generation of environmental goods and services, such as small plot to hydrographic basins. From an ecologic point of view, the use of trees can contribute to improving the productivity and sustainability of existing systems through increase in the yield of pasture and associated crops. So the objective. Our objective was development of model to identify agroforestal system to help the person to mapping the areas where the agroforestry system has been. So this project they took a duration of 8 weeks, okay? And how we did it? Well, first of all, we made a research, okay? From case of study, examples, bibliography, and all these things for take a wide point of view of the problem and the needs for resolve these issues. After we have a clear idea of how to agroforestry system works or how to identify, we make exploratory data analysis with data clean and data wrangling about image, about methodology, different kind of model of data like raster and vectorial data for store the information of agroforestry system. After that, we put all together inside TensorFlow models for make a segmentation image of the agroforestry system using a orthophoto mosaic image. And then we working on this network on containers. Okay, we use a different model for this segmentation. Okay, so first of all, case of study. We research a different bibliography about agroforestry. All of them focus on Colombia. We take a few examples for agroforestry system because we put like 1 or 2 weeks for search this information. So we found it a very, very good material where explained how to the agroforestry system works and how to benefit from this. What are the partners inside the agroforestry system? Well, we can notice that the agroforestry system is arrangement between crops and trees. Okay, so we can have, if in the first view, we can see like it's complex, right? For a person that don't have any relation with this kind of systems. But in the deep, we can see a partners between the crops and tree that make this agroforestry system. So our goal and main objective is try to find this feature inside the agroforestry system for make a classification using machine learning models. Okay, So this is a representation, a graphic representation, but how is it looks in maybe from the air, or maybe using a drone or something like that, using a satellite image, right? Well, in the file, we can see these partners between the soil, between the forest, between artificial areas, right? So we can see this partner of agroforestry system inside the image on, in this case, orthophotomosaic image, right? So after that we made the recopilation of information, we make models and algorithms and routines for try to standardize the image, right, that we found on internet and other resources, right? So the task one was the image rescaling. How we made this? We use a Rastrerio that was a special library from Python for work with image, satellite image, and geographical information, all in Python, and use notebooks, right? So this is easy for handle, it's easy for replicate, and is very, very intuitive and graphic. So the main idea with Rasterview is make a rescaling process. Why this? We make a script for take a very, very large and complex image and try to simplify it. Okay, so for example, if we have an image from 1,000 pixel for 1,000 pixel, we made a rescaling for make a new image of the half of the original image, right? For example, 500 pixel for 500 pixels. So this made more easy, more replicate, and easier to handle the information because is light, right? And the model, and we can a different model for rescaling, how the information pass to the one format to other, yes, from one shape to other, and we use a billionaire model for make the rescaling. So we use the model for in the future for any image to pass to the model, we transport this image to a new image of shape of 256 by 256 pixel. Yes, this make a image easier to handle and light and easier for transfer between the task. Okay, so we use the model of bilinear in the rescaling process and transform any image to GeoTIFF format. So this is a code that was made in background. Meanwhile, the task 2 was made. Okay. Task 2, labeling dataset. So where does the data come from? Well, we used a web page that was called Colombia en Mapas. That is a portal of IGAC, from IGAC. That is an institution of Colombia. And then we use an orthophotomosaic image. So the idea of this is use this image that was very, very heavy and try to find the best image where we can found it, the agroforestry system. So this image have a very good resolution of spatial resolution, and we have image from different part of Colombia. That was the principal area of study, and we have a different resolution and dates. The resolution is the ability for take picture from a file, and the date was the the day when the picture of the orthophoto mosaic was taken. Okay, so we had around eight orthophoto mosaic for this study, and then we use the software of QGIS for make the data labeling. Okay, so how this work? For example, this is the view of one orthophoto mosaic. Then this was the orthophoto mosaic number 564, and this is how it looks like. And then this was the labeling, right? We used polygons for delimitate the areas that was or that we believe was agroforestry system, right? So we base this using the knowledge that we get from the task 0, and then with these polygons we use a reference like a data set of forestal aerial image from cementation. This is a data set of Kegel, and with this data set we use like reference to make our own data set. Okay, so with the polygons we made a code, right? And then we tried to get the features around the polygon like a window. Okay, so after that we cut the polygon and we cut the window that was the feature in a frame around the polygon, and then we rescale with the help of the task 1, right? For example, we can see these have a shape of pixel of very big, and then we can see that after the rescaling this same image have this shape because this take a rescaling, right? And then with the polygon we made a rescaling too, but we made like a mask. What is this? We replace the data, right? We replace the data inside the polygon. So each pixel that was found in the polygon, inside the polygon, take a value of 1. And all pixel that was found outside the polygon, it will take a value of 0. So in this section, after make this rescaling and after make the mask, we have a data set, a little data set, because for example in the case of the Kegel data set, these have around 5,000 of image, and our case we have only 20 image, right, with respective mask. But in our case that was it was that we found it, right? Because it's not very common agroforestry system in all the orthophoto mosaic that was able in the portal of IGACA. So we only can found in several orthophoto mosaic. We can found a little example of agroforestry system, but we use this little data set for try to experiment with the model for see how the behavior of the data set is with the models, right? So, and in this moment, I'm gonna pass to the task 3. So I think that my coworkers can share the screen.
Yeah, thank you, Pablo. So let me share my screen. Can you give me the permission to share my screen, please?
Okay, let me okay, try again.
Yeah, can you see my screen?
Yes, I can.
Okay, then coming to the modeling part, we tried the classical machine learning model since we had limited images, like 20 images as mentioned by the Pablo. And we also tried semantic segmentation model UNet. So XGBoost is an ensemble-based machine learning model based on boosting and bagging. Let me go to the next. So we had, as I mentioned, we had 20 images of size 256 by 256 and their corresponding mass. So you can see the images here and the corresponding mass. So XGBoost model is used to train the data, and after which the model weights are extracted, and we save those for the future predictions. And here are the steps. So we use the pre-trained PGG16 framework that has been trained on ImageNet dataset, which is a large image dataset, which has more than 14 million images that belong to 20,000 classes. So we use those weights for feature extraction. We used only the convolutional part for extracting the images. We use the intersection over union, IOU score, and dice loss as a matrix to evaluate the model performance. And as I said, so we have very limited images. You can see the mask and the prediction, and it didn't perform quite well on this data set. So we tried the semantic segmentation model UNet. So we use the semantic models, which is a Python library with neural networks for image segmentation, which is based on Keras TensorFlow. It is a high-level API with 4 models architecture for binary and multi-class segmentation, including the legendary UNet model. So it has 25 backbones available for each architecture. Now, all the backbones have pre-trained weights for faster and better convergence. And we use ResNet 34 as our backbone and pre-trained weights from the ImageNet dataset. Since it's binary segmentation, we use the sigmoid as our activation function. And this is a classical UNet model. And these are the steps that I mentioned. So we trained on first with the 20 epochs and later with 100 epochs. And since we had a very limited number of images, we also use the data augmentation. Yeah, so over to you, Sukhanti.
Thanks, Pratami. Um, okay, as Deepali mentioned, we had only 20 images, and when we initially ran, the IOU score was not that great. So we thought like, okay, let's just use one of the augmentation library that's provided. It's a Python library. It's called Albumentation. Um, it's really good, and it's very highly performant library too. It creates the transformation from the original image without affecting the pixel values. That was very important to keep in mind, because there is also the Keras image generator, but didn't want to use that because we didn't want to affect the pixel values. And also this library is it integrates well with Keras, and it can also be used for all these computer vision tasks for object detection, segmentation, and detection. I took one of the picture from their website to show how this library works. You can see in that picture how the top there is the image, and then there is the mask, and then you can also see after the transformation there is a slight like rotation, and then you can see both the image and the mask are being transformed effectively. Next slide, please. So first, we ran with just the original 20 images, and you can see the IOU score was 0.74, and then the validation IOU score was very less. On the validation data, it was only 0.38, and you can see how the image is there, and then there is the label, but then the prediction was not so great. Next slide. So we added 600 more images using the augmentation. So what with that library, we just transformed the images using some vertical flip and some rotation, and we took those. We added the 20 plus 600, so we had totally 620 images. And originally we ran 20 epochs, and then the IOU score was okay, but then later we improved the IOU score by running for 100 epochs, and became the IOU score tremendously improved. You can see the validation IOU score was 0.94 there, and then the loss also decreased quite a bit. And then on to the right, you can see like the prediction. You can see how the label and the prediction also looks. Um, it was doing a very good job of predicting on the images once we augmented the images. And just we think this library is very good if you have very less images to work with, and it looks like you can do several transformation if you want to add more images to it. Back to you, Pablo.
Okay, perfect. So can you give me or the host again for share? Deepali, I think that I passed to. You have to.
Yeah, can you share now?
Let me see. Yes, I can. Thank you. Okay. Can you see my screen? Everybody can
Yes.
see? Yes? Okay,
Yes.
so after that, we're gonna pass to explain the last task. This was the development of container and using model of the bit. Okay, so David, go ahead.
Okay, so here we present the stages of a deep learning workflow. Its structure is composed of data preprocessing, model training, model forecasting, and evaluation. In this line of work, we have created two models. The first one, which I'm going to explain, is a semantic segmentation with the following elements. Can you please pass the slide? Okay, here we present the process of deep learning data preparation. As Juan Pablo has already said, the first thing that we have to make is to translate the pictures into a GeoPackage format. The second thing is to translate the labels in the form of polygons created from the images, from the pictures, and save them as a shapefiles. And finally, with the splitting of data into a training group and a test group, we proceed to run the model. Next slide, please. Okay, so SATPROC, which is the first part of our process, which relates to data preparation, is a modular package that allows us the elaboration of the training dataset based on geospatial images taken by satellite or drone images. SATPROC is an invention elaborated by the Inter-American Bank of Development as part of a series of steps to determine the location of informal settlements in Latin American cities. This SATPROC package will set the boundaries of our data, allowing us to build a database that the model in the training implementation could comprehend. SATPROC also intended to fit a bigger model with agricultural data. Could you please pass the slide? Okay. Once the images are processed, we begin to training with semantic segmentation provided by convolutional network with UNISEC architecture. After that, I'm gonna show here, we use a series of parameters that allow us to convert the geospatial images into the training samples that we want to feed the model. So could you please pass the other slide? Okay, that's very important. We need to convert the images into tensors before we feed the model. Okay, so here we present the architecture provided by UNISEC. So the first stage of UNISEC data will take converted tensor images, tensor related images. Afterward, it will increase the depth by using several convolutional networks. So we can here see the layers. The model have plenty more of that layers, but the main idea is to increase the depth and decrease the other kind of dimensions of the pictures, allowing us to have a deep comprehension of what matters in our images. Okay, so the first stage of UNISEC data will take converted tensor related images, and then could you please go back in the picture? Okay, this. And then we'll have some ReLU functions that allow us to have values strictly positive and define it from 0 to 1. Okay, so we can pass the other. Okay, so we proceed to the process of forecasting. In this case, our main objective is to determine the agroforestry areas. As the picture shows us, you might ask, in the image of the left, we have the photo taken by a satellite, and then we have the forecasting provided by the model. And you might ask, how well does our model predict agroforestry areas? So we can pass the slide, please. Okay, in this case, we can see that our result might not be the best. As important fact is the lack of available training datasets has played a significant role in the general performance of our model. However, our loss function, as you have seen, decreased significantly after the 8th epoch, and the mean IO value increased to 0.4. after the 8th epoch. Still, the performance of the model is unknown if we apply a bigger data set. So that's presentation of my part.
Okay, very good. Thank you, Juan David. So for final chapter, right, or for finish this final meeting, I have some thought for share with the team. Like we need a best data set with more image, an example of how agroforestry system looks for get better results. Because how you can see in the data argumentation with model samples, you provide a better way of the model to make better decisions. So I think that in the future we will make a data set stronger and robust for agroforestry system with a lot of example for how it look like in the real world. The implementation of containers is an idea that was made in the future, will make in the future, right? And I think that is very, very important to focus focus energy and work in these kind of topics for get a better result. So, okay, I think that is all for this meeting.